so take a few minutes to finish up our daily quiz. We're going to pick up where we left off last time with these metric prefix conversions. If you think that you can utilize our table here to perform this conversion from grams to kilograms, go ahead. All right, and then we'll go through this one at the beginning here. Is anybody else having problems with passwords? No, I think maybe your cap lock or spaces or something like that.
Oh, okay, that was good. Sorry.
No worries. All right, cool. So let's continue with these metric prefix conversions here, converting from, in this case, grams to kilograms. So we need to use our table over here, okay? So step one, we said, was we got to grab that relationship from our table that relates grams to kilograms. So some number of grams equals some number of kilograms, right? And this is what we should be able to get from our table here, okay? We said that the 1 goes with the prefix, right? That's what we're going to remember. That means that the 10 to the 3 that I get from my table here is over here on this side, okay? Another way to think about it is that's what that K means, is that 10 to the 3. So if I had, for example, you could set it up like, all right, 1 kilogram equals 1 kilogram, of course, right? But then again, what does that K mean? I'm going to switch this K to be that 10 to the negative 3. I'm sorry, 10 to the positive 3. So equals 1 times 10 to the 3 grams. All right, so again, we have our 1 on our prefix side, and the 10 to the whatever is on the other side. Okay, so we get our relationship from our table here. And step 2 is we're going to build one of those conversion factors where we stack one side of the equal sign on the other side. So I'm going to put my 10 to the 3 grams over 1 kilogram. And anytime we build one of these conversion factors, we can use it as is, or we can flip it upside down, right? So from this equals relationship, I actually get 2 different conversion factors here. They're the same thing, just inverted. All right? And so now step 3, we're going to take our original value and we're going to multiply it by one of our 2 conversion factors. All right? So I'm going to start out with my 452 grams, and I'm going to multiply it by one of these 2 conversion factors here. And I got to pick which one I'm supposed to be using. All right, and so how do I determine which one I use, the one on the left or the one on the right? I'm going to pick the one that cancels out my units of grams and leaves me with units of kilograms. That's the name of the game here, right? We're trying to jump from grams to kilograms. So which one of these conversion factors am I going to use? The one on the left or the one on the right? The one on the right, which would put grams on the bottom and kilograms on the top. Okay? So now I can tell everything's set up and I'm being really good and putting in my units and everything like that. Not just 1 over 10 to the 3, but 1 kilogram over 10 to the 3 grams. So I can punch this into my calculator. My calculator spits out 0.452. And then I'll go back and do my units. My units cancel out, leaving me with units of kilograms. And then the last step that we have to do for our math problems here in a chemistry course is sig figs, always, all right? So how do we do sig figs with these unit conversions, okay? We have this very key piece of information here, that these are all exact unit conversions. So what does that mean, okay? So let's just do an example here real quick of exact numbers. Okay, so if I said 56 centimeters, that would be a measurement that I would take using for a ruler, for example. And how many sig figs would there be in this 56 centimeters? 2. So this would have 2 sig figs. Now, if we counted off in this room right here, and I established that there were 56 students in this room right here, all right? This number does not have 2 sig figs. This number would be considered exact. Remember, the purpose of sig figs is to denote your confidence in that measurement, right? This 56, I don't know that it's 56.00. I only know that it's 56 with those 2 sig figs, okay? But if we're talking about students in this room, it's not like there's maybe 56.1 students or maybe 55.9 students, right? There are 56 students in this room. That is not a measurement, that is a count. So that is an exact number, okay? So we have exact numbers in science, and they arise for one of 2 reasons. One, either they're a count of something, just like if we counted off students in this room. Counts are not measurements, those are exact values, okay? And the other way in which we see exact numbers is through definition. All right? What I mean by that is that a kilogram is defined to be 10 to the 3 grams. All right, that is a definition. We went in there and said, this is what it means to be a kilogram. So that 10 to the 3 is an exact number. There are no, okay, so then what does that mean in terms of sig figs? Strictly speaking, it means that exact numbers have an infinite amount of sig figs. Okay? And practically speaking, what that means is when we're doing our sig figs in our calculation, when we're carrying our sig figs, we're just going to straight up ignore those exact values. Exact values are never going to limit your sig figs. Okay? So exact numbers have an infinite amount of sig figs. That means we can ignore them when we're carrying sig figs. Okay? So all of our metric prefixes are considered to be exact. They are considered to be definitions. So when I'm doing my sig figs for my unit conversions here, I'm going to look at this 452. How many sig figs are there in that original number? That is not a definition. That's a measurement, right? That's what was given to me in my problem. So how many sig figs do we see in 452? This one has 3. But now we get to our unit conversion here. And again, this is defined to be exact. So I'm just going to completely ignore that term when figuring out my sig figs. Okay? So however many sig figs we start out with in our measurement, since we're multiplying by an exact conversion factor here that we get to ignore, we just better have that same number of sig figs in our answer. Okay? So carrying sig figs, now we have these metric prefix conversions here. These are all exact, so they're just simply not going to limit our sig figs. All right. Let's do another one. I'm going to give you guys a minute or two to try to do this one on your own, and then we'll go through and do it together. Okay, so from my table, I get that 1 gigameter is equal to 10 to the 9 meters. That's step 1. Step 2, I'm going to build my conversion factor by stacking my gigameters over meters. Or I can take that and flip it upside down. Okay, now I'm going to do the math. I'm going to take my original value, my 0.405 gigameters. I'm going to multiply it by one of these two conversion factors. All right, I'm going to pick this one on the right-hand side here because that will put gigameters on the bottom. And I can tell this is set up correctly because my gigameters cancel out and leave me with units of meters. So punch this into my calculator. All right, I was trying to prove a point here using these big numbers about how big numbers look in our calculator. So my calculator spits out 4.05 E8. All right. Your calculator, depending on how big your display is, it might have just done 405, 1, 2, 3, 4, 5, 6, just giving you a big number like that. Okay. These two are equivalent. I wanted to make a point here with how big numbers look in our calculator, all right? So for everybody, take a second, punch in 5.5 times 10 to the 30 real quick, a really big number. Okay? Everybody's calculator is a little bit different in how they display these big numbers, but there isn't enough room on your screen to display it in standard notation. So what you're looking at is your answer in scientific notation, how your calculator does scientific notation. And depending on your calculator, it might look like it might say 10 to the whatever, but most calculators have this as 5.5 capital E 30. Okay? That capital E stands for the 10 to the business. The times 10 to the. That's what an E means in the calculator world. Okay? So if your number, if your calculator is displaying a number in scientific notation, some people kind of are like, I don't understand what that E means. I'm just going to ignore that back half there. That is very much so going to change your number. You can't do that. 5.5 is a very different number than 5.5 times 10 to the 30, right? We can't just chop off all those digits. So make sure you know how your calculator is displaying scientific notation. The other thing is that your homework system would accept either scientific notation or standard notation, okay? So your homework system, if you have a really big number or a really little number, oftentimes it's more convenient to represent that in scientific notation, and you would use that capital E format, okay? So again, depending on your calculator for this particular unit conversion problem, you may have seen either of these two. These are equivalent, just the same number represented in standard notation or scientific notation. Whoops, don't do that. Okay? All right, so that was just a little aside here about our calculators and scientific notation. The other thing is, if at any point you're not sure how to use your calculator, you're not sure what your calculator is showing you, whatever, just come up to me at the end of class and let's work through it. Really sucks to understand how to do a problem and not be able to get the right answer because you just can't punch it into your calculator correctly, all right? Everybody's calculator is a little bit different, okay, but we can figure it out. And that's going to be your calculator for the whole of the class, right? So once we figure it out, we'll be fine. Okay, so then units, I'm left with units of meters here. Again, either in standard or scientific notation. And then how many sig figs should I have? 3, because my initial value has 3, and again, we get to ignore these over here. Okay. All right, so now let's just do one that's a little bit more complicated. I want to know what 4.96 times 10 to the 7 milliseconds is in kiloseconds. Okay? So I'm not just jumping from milliseconds to seconds, I'm now going from milliseconds to kiloseconds. So from one metric prefix to the other. So how do we deal with this? We're going to play the exact same game. Step 1, we're going to grab those relationships from our metric prefix conversion table. The only difference is now we got to grab 2 of them. We got to grab both the relationship for milli and for kilo. Okay? So same step 1 here, but now we got to do it twice. I'm first going to look up my milli. My table here tells me that 1 millisecond is equal to 10 to the negative 3 seconds. Here's my milli entry. All right, I want you to do the same thing, but now for kiloseconds and seconds. Fill in those values there, based on our table. All right, so 1 on the prefix side, 10 to the 3 seconds. So now step 2, I'm going to build my conversion factors from these relationships here. I'm going to stack one side over the other. Again, anytime I get one of these conversion factors, whoops, I can take it and flip it. So that's my milli conversion factor. I'm going to do the same thing for my kilo conversion factor. Okay? So now we're going to take our starting value, our 4.96 times 10 to the 7 milliseconds. And we're going to pick our conversion factors here that cancel out our units and leave us with the units that we want. The only difference is now we're going to have to take 2 jumps here. We're first going to jump from milliseconds to seconds, and then we'll be able to jump from seconds into kiloseconds. Okay? So for this first step here, which one of these conversion factors, let's just label these here. A, B, C, or D. Everybody take a second and tell me what I should put over here next. What's my next step here? A, B, C, or D? B, because that'll cancel out my milliseconds here. So 10 to the negative 3 seconds over 1 millisecond. If I stopped here, what would my answer be in units wise? Seconds. So this would get me from milliseconds to seconds, but the problem's asking for me to go all the way to kiloseconds. So I'm going to need to make one more jump. I'm going to tack one more conversion factor onto the end here. All right? And which one am I going to pick? A, B, C, or D? Now I'm going to pick C because that'll cancel out my seconds. All right? So now another jump where we take 10 to the 3 seconds on the bottom and put kiloseconds on the top. Okay? And before we even do any math, before we punch this into our calculator, we can convince ourselves that this is set up correctly because milliseconds cancels out, seconds cancels out, and so the only units that I'm left with here at the end of the day are those kiloseconds, what I'm trying to get into here. All right? Cool. So let's punch it into our calculator. Make sure we can deal with these numbers in scientific notation into our calculator. Again, we're going to be working a lot with exponents, so make sure you know how to put exponents into your calculator. Okay, so this would be 49.6. Again, my units work out so that I'm left with kiloseconds. And then sig figs. All right, this number here has 3 sig figs, so my answer better have 3. I get to ignore these conversion factors because they are exact. Okay, real quick, just for the sake of our sig figs practice here, let me take this problem and change it around ever so slightly. What if instead we had 5.20 times 10 to the 7 milliseconds, and we do our same conversions here. So we're going to again convert into kiloseconds. Well, that didn't work out. So again, I'm going to first divide by the milliseconds and multiply by seconds, and then divide by seconds, multiply by the kiloseconds, so same exact setup. Okay? When I punch this into my calculator spits out 52. Again, it's set up so that I'm left with kiloseconds. And so I'm done. What's wrong here? The sig figs, right? So this is where you kind of have to be careful, is especially with those zeros, because your calculator does not keep track of sig figs. That's what you got to do at the end here. So up here we got lucky. Our calculator spit out the number with the correct number of sig figs. Don't get sort of like too attached to that that's always going to happen. This is a perfect example down here where that didn't happen. This number has 3 sig figs. My calculator only spit out 52, which has 2 sig figs. So what am I going to have to do to my answer to make sure that I'm reporting to the correct number of sig figs? 0.0, right? I got to tack that significant 0 onto the end there. Okay? We get to ignore the middle bit here, but we don't get to just ignore sig figs altogether. We still got to make sure that our original value and our answer have the same number of sig figs. Cool. All right. So on our constants page, now we know how to convert in and out of different metric prefixes using this table here. Okay? The other portion of our constants page that we're going to use is all this jazz on the left-hand side. And it looks big and scary here, but it's not too bad, all right? There's another table over here on the right-hand side. We will graduate to that later on in the semester. Okay, so let me tell you the punchline, and then we will learn how to use this table here. This table helps us convert between different units, not just changing the metric prefixes, but going, say, for example, from 5.2 inches into centimeters, jumping from the imperial system into the metric system. All right, that's what we're going to be able to do with this left-hand side of our constants page. So if we look, our constants page on the left-hand side here is broken up into your different units of measure. So we have distance, volume, mass, energy, pressure, temperature. We haven't even talked about energy and pressure yet, all right? But nonetheless, we'll learn how to use our constants page here. So if we're talking about inches and centimeters, which one of these categories am I going to look under? Distance, volume, mass, energy, pressure? Distance, right? So we can sort of zoom in here. And I have all these different relationships. This tells me that a mile is 5,280 feet, etc., etc. The one that I'm looking for is the relationship between inches and centimeters. Okay? So from this table here, step one is the exact same thing that it was with our other metric prefix conversions. We're going to take this information from our table and build one of those equal relationships. This is telling me that 1 inch is equal to 2.54 centimeters. All right, that's what this entry on this table is telling me, that 1 inch is 2.54 centimeters. Okay, so from my table now, boom, I have my relationship 1 inch equals 2.54 centimeters. What do we think the next step is going to be? We're going to stack them. We're going to build that conversion factor where we set one side of the equal sign onto the other side. So 1 inch over 2.54 centimeters. So just like before, step two, we're going to build our conversion factor. And I can always use my conversion factor as is, or what else? What can I do? Or I can flip it, right? Or 2.54 centimeters over 1 inch. All right, so I believe in y'all. Take a second, see if you can't finish off this conversion here. Taking me from 5.2 inches into centimeters. I'm going to start with my 5.2 inches. I'm going to multiply by one of these two conversion factors. And which one am I going to pick? I'm going to pick the one that will cancel out those inches and leave me with centimeters. All right? So I'm going to pick the one on the right where inches is on the bottom and that 2.54 centimeters is on the top. All right? So then I punch that into my calculator, 13.208. If I go back and look at units, my inches cancel out and I'm left with centimeters. And then I'm done. No, what do we got to do? Sig figs. Okay? So, last thing that we want to note about this table is that every one of these conversions that has this double asterisk next to it is also considered to be an exact conversion, so a definition. All right? If we look here, we got those double asterisks here. An inch is defined as 2.5 centimeters. Right? So there's no sig figs that we have associated, or rather an infinite amount of sig figs associated with that 2.54. The bottom line is that 2.54 is not going to limit our sig figs in our calculation. We consider that to be exact. We get to ignore it when we're figuring out what our sig figs in our answer is. This table is kind of designed to maximize the amount of exact conversions that are out there. Okay? So in this case, I'm only going to pay attention to my input, these two sig figs. And so my final answer, I will round to 2 sig figs. So 13 centimeters, if we were at 5.1 inches, is equal to 13 centimeters. That's what that means. All right, so that's how we're going to use this table here. Okay, and I think everybody's heard of inches and centimeters, so that might sound a little bit familiar. There's other scary stuff on here that you may not have heard about, like a kilocalorie or an atmosphere. All right, we could convert between unicorns and leprechauns as long as it's on this table right here. Right, the name of the game is just finding that relationship on our table. Okay. So let's do another one here. Okay. I would like to know what 654 grams is in ounces.
There's no double asterisk on ounces?
Correct, absolutely. So now we do have to pay attention to sig figs in that number in our calculation, right? Only if there's the double asterisk do we get to ignore it. This conversion right here is not exact, so we will have to pay attention to that. All right? Work on setting it up first, right? The setup is the most important part of these calculations. So I'm going to find that relationship on my table. This table is fairly easy to use. Let me just point out one mistake that some people make is they're like, all right, I need grams to ounces. Here's a gram. Here's my grams. Here's some ounces. Set them equal to one another. You can't just like willy-nilly pick numbers off the table, right? You're reading an entry off of that table. So I need to read this line here. I'm not just kind of picking from random spots, okay? This tells me that 1 gram is equal to that 0.03527 ounces. So from that, my relationship that I got from my table here, I can build those two conversion factors. I'm going to stack one side, 1 gram, over the other. Or I can take that and flip it upside down, so 0.03527 ounces over 1 gram. Okay. I'm going to calculate using my initial value of my 654 grams, and now I'm going to multiply by one of these two conversion factors. The one on the left or the one on the right? I'm clearly just not very creative. It's not always the one on the right, all right? For some reason, it's worked out like that today. But yes, I'm going to pay attention to my units and make sure grams cancel out. And then I'm left with ounces. So I punch this into my calculator, 23.06658. Go back, look at units. My units will work out to be ounces. Okay. How many sig figs are in 654? 3. But now, yes, as was mentioned, there is no asterisk here in this value, right? So this value also is going to, I'm going to have to pay attention to sig figs in my calculation. How many sig figs are in 0.03527? 4. Remember, we do not count those leading zeros. Leading zeros never count. So if one number has 3 and the other number has 4, how many sig figs are going to be in my answer? 3. Those 3. So my final answer here is that 654 grams is equal to 23.1 ounces. Okay? All right, so again, we're using our table here to convert units. Okay, let's do another one. Oops. Let's do 0, whoops, that's not gonna work. 0.032 feet into centimeters. Okay, so where am I going to look on my table? Distance, mass, volume. Okay, we're talking about distance again. But if I look on this table here, now I have a problem. I'm trying to get from feet, let's just put it over here. I'm trying to get from feet into centimeters. But if I look at my table here, I don't have anything that jumps directly from feet to centimeters. I see centimeters here, I see feet here, but I don't see them all in one row here. All right, so how am I going to do this? Name of the game is going to be similar to when we were doing our unit conversions, and we didn't just use one conversion factor, we had to use 2 of them and stack them next to each other. Okay? So the name of the game here is we got to find a little bit of a path that will take us from feet and into centimeters. All right? If I look, I really only have this one entry here that deals with centimeters. I know I'm going to have to use that one. That would get me from inches to centimeters, right? But I'm in feet. So can I close that gap? Is there another conversion factor up there that would help me jump from feet and into inches? Yes, so I'm going to have to use both of these in order to do this particular conversion, right? So same as before, now I got to grab 2 of these relationships from my table. This is my little path where first I'm going to start off with feet, and then I'm going to jump into inches, and once I'm in inches, I can jump into centimeters, okay? So take a second and see if you can't finish off this problem. Again, it was 0.032 feet. Into centimeters. 0.036. All right, so what I'm going to do is give you guys a little bit of a head start, and then sort of quietly work it up here on the board so that you can look up if you're stuck. So, starting out with my 0.032 feet, I'm trying to get to centimeters. So I had to grab two different relationships from my table. One that would take me from feet to inches, and then the other that will take me from inches into centimeters. From each of these relationships, I can build these two conversion factors here. All right, and which one I'm going to use, I'm going to make sure that my units cancel out and leave me with the units that I want at the end of the day. All right, paying attention to units. I can't stress enough how this paying attention to units business is going to be the name of the game in every bit of math that we do. It turns out that converting from inches to centimeters mathematically is really not all that different from figuring out how many grams of CO2 are made when you combust 50 grams of methane, all right? And that problem sounds way scarier, but the name of the game is very much so the same. Making sure that everything is set up correctly such that your units cancel out, leaving you with the units that you want. So again, in your notes, make sure you're being good and putting those units down. All right.
12 inches exact.
So if we, and we'll do sig figs here, but yes, if we look at our table here, we see that both of these have the double asterisks. All right, so take my 0.032 feet, and I got A, B, C, or D. Which one am I going to use? B, so that'll cancel the feet out. If I stopped here, I'd be in inches, but again, the whole name of the game is to get to centimeters, so I'm going to make one more jump using which one of my conversion factors, A, B, C, or D? Now I'm going to use D so that inches cancel out. And I'm left with centimeters. Okay, so punch that into my calculator. Kind of ran out of room here. I get 0.97536. My units, everything's set up correctly. Feet cancels out, inches cancel out. I'm left with centimeters. And then lastly, my sig figs. If we go back to our table here, both of these unit conversions have that exact double asterisk going on, right? So that means this is exact, I get to ignore it. This is exact, I get to ignore it. So how many sig figs should be in my final answer? The two that were in my original value here. So I'm going to round this to 0.98 centimeters. Okay. Another sort of tricky problem here, tricky unit conversion problem, would be if we had mixed units. So density, for example, so the quantity that we'll talk about later in the semester, has these mixed units like 4.5 grams per milliliter. What if I'm trying to convert that into pounds per liter? Okay. The name of the game is the same as before. Now you just got to worry about two different sets of unit conversions. First, converting from grams to pounds, and then converting from the milliliters to liters. Both of those are what you're going to have to do in your unit conversion. Okay. One way that you can set it up that'll make your life a little bit easier is to take this value here, and when you put it in your math, split up those units. So don't leave it as grams over milliliters all on the top. Put that milliliter down on the bottom. All right. So for the sake of time, I want to do one other example here. I will go ahead and I will record a video of this mixed unit conversion here and post that as well with today's lecture just so we have it. But there's one that's a little bit more tricky, so I want to make sure to go over that. And that is what happens when we have squared or cubed units. Okay? So for example, how do I go from 5.4 inches squared into centimeters squared? All right? Inches and centimeters, they're used to measure distance, but you can measure the area of something using centimeters squared or inches squared, right? So this is a perfectly viable unit here. Now I'm talking about the area of something with 5.4 inches squared, okay? So the first step is we're going to grab our relationship from our table just like we did before, all right? My table told me that 1 inch was equal to 2.54 centimeters. We're going to build our conversion factor where we stack an inch over that 2.54 centimeters. Or we can take it and flip it. But we're going to run into some trouble when we get to this third step here. We got our 5.4 inches squared, and if we multiply by this conversion factor of 2.54 centimeters over 1 inch, our units aren't going to cancel out because we start out with inches squared. So that will get rid of one of them, but my final answer here, if I leave this as is, would be in units of inches times centimeters. I haven't completely gotten rid of those inches. So how am I going to deal with this? Okay? Again, it needs to be inches squared and centimeters squared. I know how to convert from an inch to a centimeter. If I want to go from inches squared to centimeters squared, I'm simply going to take this entire thing and square it. That will square the numerical values inside, but it'll also square my units as well. So what I'm going to punch into my calculator is 5.4 times, not just 2.54, but 2.54 squared. You can divide by the 1 squared as well, although 1 squared is just 1. Okay? So how do we deal with these exponents here? We're simply going to take our normal conversion factor, and we're going to raise the whole thing. Notice how I put parentheses around the whole thing, so it squares both the top and the bottom, as well as the units inside. Okay? So 5.4 times my 2.54 squared. Now I get 34.838. And again, because of this square here, now I'm in inches squared. That does cancel out, and I'm left with centimeters squared. Okay, that conversion factor would still be exact, so I would round my final answer here to my 2 sig figs, or 35 centimeters squared. Cool. All right, survived week 1. Fantastic. Okay, cool. We will pick up with this next week, and next week we actually get to start talking about chemistry, start talking about atoms and all that jazz.
For this problem, I kept getting 4.05 times 10 to the power of 10. And I did it like multiple times.
You have the 1 on the wrong side. The 1 goes with the prefix. The 1 goes with the gigameter. The 10 to the 9 goes with the meters. So your numbers are in the wrong place.
Oh, okay.
Yep. So, for example, here, the 1 is with the prefix, right? It should be 1 gigameter under 10 to the 9 meters.
Okay, thank you.
The dash, that means no prefix. So, like, for example, centimeters, if we got rid of it, it's just meters, right? So the dash is like the absence of a prefix. So just the base unit.
Thank you.
Yep.
For the exam, for the state, I think so.
They will provide you with your scan.
Okay.
Yeah.
I have a question about the exact measurement. So, you know how if you were to measure something in a beaker, would it be considered an exact
No.
measurement?
So measurements are not exact. What are exact are counts, if we count how many people there are, okay? Or something that's defined that way.
So that would be infinite.
Yes, and that's an infinite number. So this 2.54 centimeters equals 1 inch. That is the definition of an inch, is 2.54 centimeters. Scientists everywhere say what it means to be an inch is 2.54 centimeters. So that's why that's an exact number. But all measurements that you take have significance associated with them.
Okay, so I wouldn't have to.
This, you basically, you don't have to worry about them in your calculation. They're not going to limit you.
Okay, thank you so much.
Yep. No, it's going to be on the exam. So everything that's on that constants page is what you can expect to have on your exam. Yep. Oh, you look next door. So 2.56, you're going to look at, if you're rounding here, you look at the value of this number here. 5 and up means you round up. 5 and up. Below 5 means you round down.
So yeah, so give me one